So, I would like to establish whether or not this vector field given by 2x cosine of x squared plus c squared plus sine of x squared plus c squared, sorry, whatever the first thing I said was, comma, sine of x squared plus c squared, comma, 2z cos x squared plus c squared. I want to know, is this the gradient of something?
Since it's 3 variables, we have to do that huge formula thing, right?
Since it's 3 variables,
Sorry, it's an IJK.
huge
It was
formula.
like gigantic,
Just did a partial.
like the test.
Oh, yeah, I wouldn't probably do curl on this one. Right, there is a 3-dimensional curl. We could calculate that for this, check if it's 0. That would be one option. Maybe a better option would just be to try to brute force it and see if it works. The curl thing is a nice thing to compute in 2 dimensions, and it's a slightly more cumbersome thing to compute in 3. So what I would do is I would just say, okay, this beginning bit, 2x cosine of x squared plus c squared, right? What's that supposed to be?
That's supposed to be the partial of that. Yeah, x.
Yeah, that should be the x partial, right? Sine of some stuff, that should be a
Partial y.
y partial. And 2z cosine of x squared plus z squared, that should be a,
Partial z.
yeah, that should be a partial of f with respect to z. Okay, so which one do you start with?
The next one.
X.
Let's start with x. Okay. So I'm setting up, okay, f should be about what?
Sine x squared plus c squared.
Okay, so about the antiderivative of 2x cos x squared plus z squared. The x, which you might notice is sine of
Yeah.
x squared plus z squared
Plus some yes.
plus
Plus a constant function of y or z.
some constant that's a function of y and z maybe. Okay. All right. What do I think about? Right, that was maybe my first guess for f. What's my second guess for f?
Just y times that whole chunk.
Right, so all this stuff, sine of x squared plus z squared, that's constant with respect to y, right? So when I integrate that stuff with respect to y, I'm going to get that thing back, right? So I'm going to get sine of x squared plus z squared plus, oops, sine of x squared plus z squared times y plus
C x z.
some constant, might be a function of x and z.
Yeah.
Okay. Can I reconcile those two things? Why not?
Because you can say that the first thing is the cxt, but the z.
Yeah, so, okay.
Z.
This stuff clearly doesn't match that thing, right? The sine bits, although they look very similar, right?
Yeah.
This one doesn't have a y and this one does. So what I'm looking for is this thing, right, is my second guess, my first guess. The bits with the signs, they don't work. So best I could do is I could say, okay, this thing has to be
Oh.
sine of x squared plus z squared, right?
But the c.
Okay, so hang on. If that has to be sine of x squared plus z squared, then I've got sine of x squared plus z squared times y
Yeah.
plus sine of x squared plus z squared. Right, this should be like an improved version of f2.
But it's not. It doesn't work.
The partial with respect to x would have two things.
Yeah, but if I took the partial with respect to x, right, I'm going to get some extra stuff, like specifically a y left over. Okay, see that? This is not a gradient. Yeah.
Yeah, the solution manual, I was really confused because they used the curl of F
Yep.
and they turned all the Z's to Y's.
Oh, that would be weird.
It still wouldn't work.
It doesn't work, but I just thought,
Oh, they just
understand.
literally transposed some variables?
Yeah, they just swapped them out.
Yeah. I don't know why they would do that. Presumably typo. But yeah, we could calculate the curl of this, right?
Yeah.
That would be another option. We would see pretty quickly that that's not zero either. Cool.